Today we will be discussing protection mechanisms. I am Kester Rawlins and this is iTech 360. When we are talking about protection mechanisms, let's think about a system. So, therefore, in a computational system, multiple processes might be running concurrently. Each process has the capability to access certain memory locations and to execute a subset of computer instructions. The execution and memory space assigned to each process is called a protection domain. Protection domains typically protects programs from unauthorized modifications or executions interference. So when we think about a computational system, we can talk about trusted computer base, other words, TCB. What is TCB? Basically, TCB is the total combination of protection mechanisms within a computer system, which is trusted to enforce a security policy. Therefore, this encompasses various aspects of the system. For example, the hardware, software, and firmware. Security parameters. These are boundaries separating the TCB from the remainder of the system. Trusted path. This is to allow a user access to TCB, trusted computer base, without being compromised by processes or users. So therefore, it's a safe path in allowing a user to access the trusted computer base, known as the trusted path. Trusted computer system. Basically, users or uses its hardware and software assurance measures to process multiple levels of classified and sensitive information. In this slide, we will be discussing protection rings. Here we have a diagram showing how the protection ring functions. So if we look to the right of the slide, this section to the right of the slide is CPU modes and protection rings. You can see it looks sort of like a bullseye with the center and outer rings expanding from the center ring. The innermost center ring is known as ring 0. So let's just elaborate on this a bit. What are protection rings? Protection rings provide a security mechanisms for an operating system by creating boundaries between various processes operating on a system and also ensures that processes do not affect each other or harm critical system components. So if we look at ring 0, which is the most center ring, we can say that's if it was a target board, that will be bullseye directly in the middle. The ring 0 is the operating system's kernel. This is kind of like the boss. This is the supervisor slash privilege mode access in the protection ring. Ring 1, which is the other outermost part of the ring, is responsible for the operating systems. Those are the remaining parts of the OS. Ring 2, which follows, is another part of the operating system, but these are responsible for I/O drivers, input-output drivers, and OS utilities. Ring 3, which typically is responsible for application programs. If we see here, if you can follow the mouse cursor, you can see the outer ring. So it's responsible for application program. So once again, we have the ring 0, which is the crucial sector, such as the supervisor slash privilege mode. We have ring 1, reserved for OS services, then followed by ring 2 for device drivers and OS utilities, and ring 3 is application programs. These have the least privilege. Security labels. A security label is assigned to a resource to denote a type of classification or designation. A label can indicate special security handling or can be used for access control. Once assigned labels, usually these labels cannot be altered and are effective access control mechanisms. Security modes. Information systems operate in different types of security modes. These security modes are determined by classification level and the clearance of the user. An example of this could be you're working in an organization and you have access cards, right? You will not have access to every part of the company. Some areas would be sensitive. Let's say if you're not into IT and you're in an IT company, you will not have access to the server room, or you might not have access to the maintenance area, right? So there are different levels of security modes. We have system high mode of operation. This is where the system operated at the highest level of information classification, where users must have clearances for the highest level, right? So therefore, we're seeing that this is a very high mode of operation and special access is required in this mode. Well, this mode basically gives special access and higher levels. Multi-level mode of operation. This is where users have different clearances and data at multiple classification levels. So when we're thinking about security modes, there are also additional types of or additional mode of operations in security modes. For instance, there's dedicated security mode. This is where all users have a clearance or an authorization and a need to know for all information that is processed by an information system. A system might handle multiple classification levels. There is also compartmented. All users have clearances for the highest level of information classification, but they do not necessarily have the authorization and a need to know for all the data handled by the computer system. There is also controlled type of security mode. It is a type of multi-level security where a limited amount of trust is placed in the system's hardware and software base, along with the corresponding restrictions on the classification of the information level that can be processed. Limited access. It is a type of system access where the minimum user clearance is not cleared and the maximum data classification is unclassified but sensitive. When speaking about security mechanisms, there are additional security considerations. These considerations may be vulnerabilities. So therefore, vulnerabilities in the system security architecture can lead to violations of the system security policies. Some vulnerabilities architecturally related are as follows. There is the covert channel. This is an unintended communication path between two or more subjects sharing a common resource, which supports the transfer of information in such a manner that it violates the system security policy. The transfer usually takes place through common storage area or through access to a common path that can use a timing channel for its unintended communication. Covert channels like covert operation. Lack of parameter checking. The failure to check the size of input streams specified by parameters. Buffer overflow attacks exploits this vulnerability in certain operating systems and programs. Maintenance hook. A hardware or software mechanism that was installed to permit system maintenance and to bypass the system security protection. This is sometimes called or referred to as a trapdoor. Another form of vulnerabilities are the time of check to time of use attack. This is simply an attack that exploits the difference in time that security controls were applied and the time the authorized service was used. Recovery procedures. Whenever a component of a trusted system fails, security policy requirements of that system should not be compromised. Recovery procedures should not provide violation of the system security if a system restart is required. The system must restart in a secure state. Therefore, you cannot have an alarm system in your home and let's say something happens to the alarm and it needs to restart. When that alarm restarts, if it was previously in the armed mode, it should restart and go back in the armed position. Startup should occur in maintenance mode that permits access by only privileged users from privileged terminals. When discussing recovery procedures, there are different types of recovery procedures. One of them is known as fault tolerance system. In a fault tolerance system, the system is capable of detecting a fault occurred and the system has the capability to correct the fault or operate around it. Sounds pretty good, huh? There is also a type of fail-safe system. This is where program execution is terminated and the system is protected from being compromised when a hardware or software failure occurs and is detected. So we can see here these two types of systems operate differently. There is a fail-safe system and there's a fault-tolerant system. Of course, the fault-tolerant system would require less interaction or interference from the user or the security administrator as compared to the fail-safe system where the execution of the program is terminated, right? There is cold start. This occurs when there is a TCB of media failure and the recovery procedure cannot return the system to a known, reliable, secure state. So these three types of systems are what we can think of as recovery procedures and the systems associated with recovery procedures. Thank you for listening. This was a presentation on protection mechanisms.